In this video, we're going to look at the nomenclature of alcohols. So the alcohol is the highest priority group that we've looked at so far. So the alcohol will be higher in priority than a triple bond or a double bond, and higher still than X being a halogen or R being an alkyl group. So we're going to number any given chain to give the alcohol the lowest possible locant, kind of ignoring those other groups because of the alcohol's higher priority. So we'll look at a simple example first and see how the alcohol modifies the parent chain name. So this parent chain is 4 carbons long. I'd start numbering at the carbon with the alcohol attached to give it the lowest possible number. So but is the prefix for 4. So if there was no alcohol, it would be butane. Instead, it is 1-butanol. So this OL is what tells me that I have an alcohol on my chain. And instead of having an E there, butane, OL is the modifier for an alcohol. You could also put the locant right before the modifier, so you can either say 1-butanol or butane 1-ol. Either one of those is appropriate. So now let's add another substituent. So now I have 1, 2, 3, 4, 5, 6 total carbons. And if I started from the left-hand side, I would run into the bromine first. It's at the 2 position. However, the alcohol is the higher priority group, and if I went from the left, it would get a 4 for its locant. Whereas if I go from the right, it would get a 3 for its locant. And so I would number from the right because the alcohol is the higher priority group, so I number in a way that gives it the lowest possible locant. So this is going to be a hexanol derivative. It's 3-hexanol, and then I've got a bromo substituent. So out in front, we would have 5-bromo, and then again, I could put the locant either here or within the chain name, but 3-hexanol. So in another example here, I'm going to have an alcohol, and I'm going to add a double bond here. Okay. Now a double bond modifies the parent name at the end of the chain, similar to what an alcohol does. And so if I number again to give my alcohol the lowest priority, this chain is going to be a hexenol. I think the easiest way to do this is to put the locant directly before each modifier so that it's easy to see what is being modified. So I've got a hex 4-ene 2-ol. So this locant tells me about my double bond, and this locant tells me about where my alcohol is. Okay, and then hex tells me that I have 6 carbons. So I have a 6-carbon chain, there's an alcohol at the 2 position, there's a double bond at the 4-5 position. So now we'll look at a situation where we have more than one alcohol. So I'm going to make a triol here. Put some methyls on it too. So 1, 2, 3, 4, 5, 6, 7. So this is going to be a heptane triol. And I've got 2 locants on here for my methyls and then 3 locants for my alcohols, even though 2 of them are on the same carbon. So this would be a 5, 6 dimethyl 2, 3, 3 heptane, and then what's kind of funny is you keep the E when you have more than one alcohol on there. Triol. So if you have 2 alcohols, you would have a diol. If you have 3 alcohols, you would have a triol. It's just going to modify the exact same way. And when you have more than one alcohol on your molecule, you leave the E in the parent name. So I'm going to do a side-by-side comparison on the next slide. Okay, so in this case, I've got 1, 2, 3, 4, and 5. So this would be 1 pentanol, okay, but no E because there's only one alcohol. If I took the same thing, put an alcohol on this end too, 1, 2, 3, 4, 5, and it wouldn't matter which side I counted from because I would get a 1, 5 either way, but this would be a 1, 5 pentane diol, and you can see that I left the E there. So if there's ever more than 2 alcohols, or more than one, I should say, 2 or more, then you're going to leave the E there. So you leave this E. If not, if there's only 1 alcohol in your root name, then it's just the OL. And you take off the E.